out of the gate, currently PCG points do not know what is around them. They don't know their surroundings. They don't know where there's a wall, a mountain, a sheep. But what if you could actually get that information? And what if it was actually pretty easy to do so? As you see right here, my points are actually all on the ground. I have just a nice layer of points, but I'm placing frames and shelves on the walls, and they're actually getting to be placed right where they need to be with the right angles and everything. And you can see even on the back, it is all being placed. Now, of course, there's things hanging off, and that's to do with just the pivot of it. As you can see, no matter where around it is, we are placing these points not where they are, but where we want them to be on the walls. And like I said, this is all actually really simple to do. So let me show you how to do that. To get started, I'm going to create myself a PCG graph, a PCG underscore wall deco, and I'll grab myself a blueprint class actor, and this is going to be our BP wall deco. Open up your blueprint, and now in here, we're going to need to add a spline component. This is where we're going to want to specify where we want to search, as well as our PCG graph that we have created. Go ahead, add it in, and select your graph from the dropdown. With your graph populated, I'll go ahead and just make this area just a little bit bigger and hold Alt to drag out a few extra points. And then in the detail panel, I'm going to search for closed and turn on closed loop. Now, of course, if you want these to be linear points, you can go ahead and make your points linear. For me, this is all fine for this demonstration. Now, let's open our PCG graph and get started in here. To begin with, I'm going to right click and search for get spline data. This gets our spline that we just created in the blueprint. And then we're going to get a spline sampler. Now, inside of the spline sampler, instead of on spline, we want on interior. And for the spline sampler, I'll leave it probably at 100, but I'll change the interior border spacing here to be 50 so we see an actual gap from here. So now if I drag my blueprint onto the level, and then I press D to sample the spline sampler, you can see we now get a nice actual grid here, exactly where we kind of have our bounds. And if we want to, we can go ahead and split this out here and expand our bounds to cover the kind of area that we have. Now, at the current moment, this doesn't know anything about what's around them, but there are a few things we want to take care of first. Now, at the current moment, this doesn't know anything around these points. It doesn't know about these walls. It doesn't understand anything. It just knows itself. And what we can do is make use of traces inside of Unreal that can trace their surroundings from every single point and get the information around them using a custom node. And don't be afraid, the custom node is actually quite simple to set up nowadays, because you can just use one of the pre-made custom nodes that Unreal already provides for you and just modify a little bit to get your desired result. So to do that, I'm going to drag execute blueprint here from the top left, drag it onto the graph, and the blueprint element type, I'm going to select absolutely anything in here. It doesn't matter. And then I'm going to click the browse to asset in content browser. Now, chances are it's going to bring you over to this deprecated folder. Now, we don't want this. We want to go up a level into this BP elements folder. And here you can see a few graphs here that's already been created. And what I'm going to do is I'm going to grab the distance to density node. I'm going to scroll up to my PCG folder and I'm going to drag it over and then copy here. This puts a copy of the distance to density node right into my folder. And I'm going to rename this to detect surroundings. And let's open it up. Now, custom nodes are a little bit different, but they're still blueprints effectively. As you see, when you open it up in the event graph, you actually won't find anything. In fact, it's all in functions here to the left. If I open the PCG graph and everything below it, execute with context is actually effectively your execution graph. This is where it goes, grabs the points, saves all the information from it, does the loops, there does a point loop with the info, and then saves it and exports it. And it's not really needed that we actually even modify any of this. We can leave all of this exactly how it was. So we'll do just that. On the left here, though, under node title override, if I double click that, this is the name that appears right here when we select it. So if right now it says attribute to param data, because that's the one we selected. If I press this arrow with our blueprint that we copied still selected, it'll say distance to density, because that is the node. And now if I go ahead and change distance to density here to detect surroundings, and now I hit compile, you can see if I refresh it by just pressing the arrow again, it says detect surroundings because it has gone ahead and refreshed it. The other thing you might want to change is the class defaults here on the right. You can have it be exposed to library under a category. Here it's under category density. I can put it under my custom category and I can add a description if I'd like. I'll go ahead and clear it for now. And if I compile and save this, here on the left, you can see I have detect surroundings under custom. And I can just drag it in the future. Now I have a find nearby object. This was the same thing that I was doing just for a test. you won't have this one, but the detect surroundings now can just be dragged in from the left very easily, so you don't have to go searching for it. But excellent, now we have this. Now how do we get it to do what we want? So in this graph, the last thing we have is this point loop body. If we open it up, all this is doing is going through the points one at a time. It is getting the information from it, it's doing something with it, and then it is outputting it. That is all this is. So here, if I go ahead and select all of this and delete it, I'll delete 2 of the 3 outputs, and I'll bring the last one kind of over closer. I can then go to Edit, delete unused variables, delete everything that we just don't need. The last one we have here is the PCG volume actor. In the execute with context, we can even remove that one. That's this guy right here, where we get the original component, get the owner, and the PCG volume actor. I can hold Control and just drag it all the way to the left here, and we can just delete this as well. Again, delete unused variables, delete. And now we have removed everything that we don't need. And now all we need to do is put whatever we want to actually have the points do right in here, and we'll be done. So for demonstration, if I take this point loop body and I just bring it all the way through, and I take this in point and plug this into out point, return value being checked is important. If this is not checked, the point will disappear, it will be gone. So make sure it is checked if you want the point to actually exist afterwards. But with this happening, you'll see if I plug this in now all the way through, and then sample the detect surroundings one, it looks exactly the same. Because we are not doing anything. It's just going through the graph, through the custom node, and it's not doing absolutely anything. So now what we need to do is find the information about what is around them. There are multiple ways of doing that. I'm going to use a multi-sphere trace. What this is going to do is check a radius around every single point, and then if it finds something that I specify, then it can output the point. And if it doesn't, then it won't. And the reason I'm using multi is so that way, if you put it into a corner, it will find both of the walls, for example. So right here, from the point loop body, I'm going to drag out and search multi-sphere trace for objects. Now, I wanted to start where the point location is. So I'm going to take this in point, and I'm going to search for break to break the PCG point and get the information from it. And I'm going to right-click on the transform and split it to get access to the location, rotation, and scale. Now, the location, we can actually plug into the start and end. It'll be exactly where the points are. But realistically, I want these to be higher up on the walls. I don't want it to be exactly on the ground where this samples. So what we're going to do is drag from transform location, search for add. Instead of typing in plus 100 in the Z, for example, I want to be able to control this. So I'm going to right-click on the second vector, and I'm going to split struct pin. This gets me X, Y, Z input separately. And I'm going to right-click on Z and promote it to a variable. I'm going to call this height trace offset. And the detail panel, I'm going to make it instance editable. Now, when I hit compile, this gives you an error, but that's because nothing is plugged into here yet, so don't worry about that. But the main thing is, this variable, because it's now instance editable, in our graph, if I open it, you can see it is actually available right here, height trace offset. So we can plug things into it and control it dynamically if we so wish. So let's plug this into our start and our end. And now I want to control the radius dynamically as well. I'll set the radius by default to be 100. I'm going to right click and promote to a variable, leaving it named radius and also making it instance editable. From here, we need object types. So if you drag out of object types and you search for make array, you can specify what kind of things are you actually searching for. Now, in my case, these walls are all static objects and they're default static mesh actors. So I can specify just world static here, but if I wanted to, I could add pins and I can say, we also want to get dynamics, pawns, etc. And if you have your own custom collision types, you can always add them here as well. And if you don't need something, you can right click and remove array element pin. For us, world array static is perfect. And depending on how you set up your collisions, you might want to trace complex. But if you have nice collisions or it's fairly simple objects that you're looking for, this will do just fine, as tracing complex is a bit more expensive. So what does this do already? Well, if I go ahead and just drag this all the way through, and I'll ignore everything else, drag the point all the way through as well, and I hit compile, you can see when I tap compile, nothing actually is changing, nothing's visible here. But here in the multi-sphere trace, if I change this to for duration, and then I hit compile, you could see it is now lots of little spheres, and we have green where we've actually hit the actual walls. Again, I'll hit compile, and you can see it has found walls all over here, which is great, and has not found them here. Now, something to be aware of, if you have tons and tons and tons of points, like thousands of them, or depending on your machine, maybe hundreds of them, it all depends on your setup. Be careful of doing for duration or previewing this. First, make sure you sample it with only a few points, and then make sure you got the settings correct, and then increase your point count. I have found that when you're doing things like for duration and you're sampling thousands of points, let's say, it can actually go ahead and crash Unreal. Now, it will work fine in actually using this, but specifically in PCG, if you were to try to debug for a duration and have way too many points that your computer can handle, it will go ahead and crash. So just be aware of that and use small numbers. But now we want to filter out the things we don't need. So let's go ahead and detach here. Now I'm going to use a branch node right off the multi-sphere trace, and we only care if it is actually hit something. If it didn't hit anything, then I just wanted to return nothing. So I'll plug in the return node and turn off return value. I don't need to plug anything else in here. It just returns nothing. It is deleted. But if it did hit something, we need to know what it hit. So from this out hits, I'm going to drag out and search for each loop and plug that under true. I now want to actually spawn points based on where it hit. So from array element, I can drag out and search for break. And this gets me the information of every kind of info from that trace, like its location, the impact point, the normal, the name of the things, if it was bones, lots of great information here. But the main things we need are the impact point and the impact normal. So what I'm going to do is from the start here, I'm going to drag out this end point, drag it all the way to the right, let go and search for set members in PCG point. And that is going to be plugged in from our loop body. Now, the thing that we want to overwrite is here in the detail panel, we want to overwrite its transform, where that point resides. So I'm going to right click on transform and split it. And for the transform location, I want to put in the impact point. This is exactly where it collided with the object. And then we have the impact normal. Now we can't plug in a vector into a rotator, but what you can do is from the impact normal, you can search for rotation from X vector. And this will convert your impact normal into a rotator that you can just go ahead and plug in. Now the scale, we would like to have info from that. So we can actually take the scale all the way from the start here. Whatever it was at the beginning, go ahead and just pipe it all the way through and can close this break hit result up and just clean up our graph a little bit. Now that we have this, all we need to do is output the final point. So we grab this return node and we can just go ahead and duplicate it over here. If you don't have this or you delete all of them, you can just right click and search for return node and grab it that way as well. Then you grab the set members execution to the execution and the struct out into the endpoint and make sure the return value is set to true. Again, if you don't have this checked on, the points will not be there. I'm going to turn off for duration since we already know that is working. I'm going to turn it back to none and hit compile. Immediately you can see there's all our points right on the walls. Now there's a few things you might notice is, well, we have points kind of on top here. We have them on below. And if I was to come inside, we also have them on the inside here. So you're able to filter out points based on the distance and anything else you'd like at this point. As always, the project files for this are going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord is down in the description as always. Thank you again to the Patreons, and let's get back to it. So let's actually add a few of the controls we have exposed here, like the radius and height trace offsets, into our blueprint graph so we can control this dynamically. So under this BP wall deco that we created before, I'll add two variables. The first one being height trace offset is going to be of type float, and it's going to be exposed. You hit the eye icon here on the right. I'm just going to duplicate it and call the next one radius. And now I'm going to compile it. For the radius, we'll set the radius default to be 100 and the height trace offset to also be 100. And now in our PCG graph, let's open up this detect surroundings. And now I want to plug in our variables that we got exposed in the blueprint. So right click, search for get actor property. And the right here under property name, we want to type in exactly the things we have typed in. So for example, here we have height trace offset. And to make it easier, I'm going to select it, copy it, and then paste it here into the property name. And when you have the name exactly correct, the error goes away. Then you plug that into the correct input. I'm going to duplicate it. And the second one is radius. And I'm going to plug that into our radius and close it up. Now from here, just so we don't have to sample the points, I'm going to drag out, search for static mesh spawner. I'm going to add a few mesh entries here and plug in our meshes. Under here, under static mesh in the descriptor. Just like in the demo you saw, I've plugged in the frames and a shelf. And now if we take a look, well, this doesn't seem right. They seem to be kind of angled incorrectly. That's because if I open these shelves, X is to the right. They're not facing X forward. They're kind of doing Y forward if you were thinking Y is forward and back in this direction. So if that's all your meshes, we can just fix that with a simple transform points at the beginning here. searching for transform points, plugging that in right in before that, and I'll offset that by -90 in Z for minimum and maximum. Just like that, you can see everything is, well, on the walls, exactly where we want it. Now there's some, sometimes in the corners, it gets kind of confused in those exact corners, but the majority of times it is actually really good and follows the contour of this wall. And now what we can do is with our blueprint selected, we can control the height trace offset, like you make it lower. But you see, when we make it lower, it is now grabbing the points here on the down below area. We don't really want that. We want kind of only on the outside. So what we can do is we can modify the trace and things of that nature, or we can make sure that it is cutting out the points where these are. I'm going to do is select all of these walls, and the detail panel, I'm going to search for tag, and under actor tags here, I'm going to add a new tag and call this one wall. What we're going to do is cut out any points inside of this wall so they're not spawning there. So right before this detect surroundings, I'm going to drag all of this to the right. From the spline sampler, I'm going to get ourselves a difference node. This is going to help us cut out what we don't want. And for the cutout, we're going to right click, get actor data. And in the details, instead of self, we want all world actors by tag. And the tag that we specified is wall. We also want to make sure select multiple is checked on, mode get single point. And depending on how your bounds are set up, you might need to uncheck track actors only within bounds. For my case, I'll leave it on because all of my walls are within the bounds of that spline. So I will go ahead and plug that into the differences and plug the differences into the detect surroundings. And what you'll see is the points down below that were there before are gone. We don't have the points in here anymore. That's because if we were to sample this difference node, you could see the points right inside the walls are now eliminated. And so we don't have this issue. But in our case, I'll go ahead and raise the height trace offset back up. And one thing I want to show here is what happens when you increase or decrease this radius. If I decrease the radius, let's say 25, you'll see actually a lot of them have disappeared. And depending on how close it is to that original point, which is these guys right here, it will either be there or not. So depending on how you have configured it, where maybe it needs to touch or maybe it needs to be far away, it will go ahead and spawn or not spawn. As you can see, this one's a little bit farther away than these. And so the ones here have not spawned. If I increase the radius to 30, you can see the spawns begin. If I increase it further, we get more and more. But if you were to increase this way higher, let's say 200, you can actually get points spawning in from the other side because they'll also hit on both sides because it is now larger than the gap between the points. Now, depending on your use case, this might be a good thing or might be a bad thing. Maybe you wanted to sample in through a wall. As you can see, it is now really simple to set up. And we can actually even give a little bit of a rotation here. So here in the transform points, we can just set up a little rotation min of minus 15 degrees to 15 degrees in the Y. And we get a little bit of play here where these are now rotating a bit randomly. And if you want to get a second story to this, for example, you don't need to have detect surroundings multiple times. All you do is from this difference node and this converted into points node, I'm going to ourselves a transform points. I'm going to offset the Z by 100 in min and max. And then I'm going to use a merge points node to merge the original points with this offset and plug that into the detect surroundings node. So the graph ends up looking something like this. And now we have, well, two levels, but they're exactly the same. When you go ahead and use the transform points like this, in order not to have it exactly the same from below to above, make sure in this transform points, you want to recompute seed. Check that on. This makes sure that every single point gets its own new unique information. And as you can see, we now have differences between the top and bottom. Even when they're the same, the rotation is a bit different. Of course, I can also go ahead and do something like having it a little bit off between 100 and 125 up. And now we're getting a little bit of play with the verticality here. And we can do the same thing for a multi-trace for here to get a little bit more play area. But this is how you take points that are originally on the ground and sample the surroundings. Now, I've demoed it with walls. So if you want to do something like an interior, you can use this to just find where your walls are in a room and place things on those walls. But you can also have it detect characters, objects, whatever you'd like, as long as you trace for it and you specify what kind of trace you want. You can even go ahead and expose the array where you specify what kind of thing you're tracing, and then you'll have even more control that way. And from what I heard, in 5.5, we are getting traces in PCG, but what kind of traces, how that's going to work and everything remains to be seen. In the meantime, I hope you guys have enjoyed this. If you want to learn some more PCG, check out this video right here. That thing you're going to really enjoy.